So hope you understood what is resonating structure is. Resonating hybrid is also clear to you. Now just one more term that is required or that is left over, and that one is the dipole moment. Just we are going to discuss about dipole moment now, and as we finish up with the dipole moment, the terms of ours will be over, and then we can move next day to the to the next theory, that is valence bond theory. We can move to the valence bond theory next day, but till then we can find out that what is the dipole moment. What is dipole moment? We just want to know that what is dipole moment. Okay, so the next term is dipole moment. Now what is dipole moment? We must understand that what is dipole moment. From the word itself we can understand what is dipole moment. What is dipole? Dipole means two poles, positive pole, negative pole. Okay, let me take an example, you can understand it better. Okay, suppose we are talking of HCl, hydrogen chloride. Hydrogen is there, chlorine is there. Hydrogen is giving one electron to be shared, chlorine is giving one electron to be shared, and that one pair of electron is shared. Now the question is, this is hydrogen's electron, this is chlorine's electron, right? Okay, this pair is shared. Now the question is that where this pair will be present. Where this pair will be present if the hydrogen and chlorine are sharing the electrons to form a bond. Where these electrons will be present, will they be, or will that pair of electron be present towards hydrogen, towards chlorine, or in the middle? That is determined by, you had studied this, that is determined by the factor called electronegativity, if you can remember. Okay, that is determined by the factor called electronegativity. What is electronegativity? It's the tendency to attract the bonded pair of electrons. And we know that the electronegativity of chlorine is much more in comparison to that of hydrogen. Okay, because as we go from left to right, the electronegativity increases, you know. If we go from top to bottom, the electronegativity decreases. Maximum electronegativity is fluorine. We had studied all this thing in periodic table. Okay, so we know that out of hydrogen and chlorine, chlorine is more electronegative. So the electron pair will be more towards chlorine. What does it indicate? Though it is shared, but hydrogen partially is losing the electron, partially it is going away towards the chlorine, and chlorine is partially gaining the electron, it's coming towards the chlorine, partially it is gaining the electron. Since partially it is losing the electron, it is becoming partial positive charge because it is partially losing the electron. And since it is getting partially attracting the electron, this chlorine is partially attracting the electron, it is getting partially negatively charged. So the HCl molecule actually is becoming like this, HCl, but H is delta positive and Cl is delta negative. Delta means partial, okay? Partial positive charge and partial negative charge. Hope you understood that. And when it is happening? It is happening only when the polarity varies, means the bonded pair of electron is shifting. The bonded pair of electron is shifting towards one side. And when it will shift? If the electronegativity difference is there, whichever has got more electronegativity, it will shift towards that. Okay. Now since two poles are there separated, two charges are there, positive charge and negative charge, separated by a distance, the bond length, it is responsible for the generation of dipole moment. All of us know moment. In physics you must have studied that, okay? Dipole moment should be equal to, mathematically we can write it nothing but charge into distance. So whatever is the charge in the atoms, That charge into distance between the atoms is the dipole moment. That is first point. Second point, it's a vector quantity. Dipole moment is a vector quantity. Okay, it has got a direction, and the direction will be always from positive to negative. This is negative. See, I am drawing it like this. This is negative and this is positive. It is from positive to negative. The dipole moment's direction is from positive to negative. Okay, that's the direction of the dipole moment, which is a vector quantity. That's second thing. The dipole moment means what? A dipole is generated, positive and negative poles are generated, and they are separated by certain distance. If they are separated by certain distance, a moment will be generated. A moment, torque, I hope you have studied it or you will study it in physics. Okay, the moment will be generated. Moment is a vector quantity, and that moment is called, moment means not pul, वो नहीं है, वो moment नहीं है. Moment is physical quantity, I am telling. Okay, that moment will be generated, and that moment is known as dipole moment in this particular case. Okay, which is a vector quantity and whose direction is from positive end to the negative end. It is directed from positive end to the negative end. The vector quantity's direction is that. Okay. Now, whether a molecule is, this is to just HCl I have taken. Obviously, if I ask you that is HCl shows dipole moment, you will say yes. Okay. Now, just I will take two examples simply. We are going to do a lot, but not now. As the time comes, now we are just going to know the basic things. Okay, we are going to, I'm going to take just two examples. One is carbon dioxide, one is water, or one is, suppose carbon dioxide bhi chhod do. Beryllium chloride, BeCl2 and H2. Beryllium chloride and H2. Two examples I am going to take because you know it already. That is why I am going to take this. BeCl2, BeCl2. Is it the structure of BeCl2? Tell me, is it the structure of BeCl2? Is it linear? We have seen that it is linear. Yes. Now chlorine has got more electronegativity. This chlorine has got more electronegativity. So it will attract the bonded pair of electron towards it. So beryllium will lose partially. So this chlorine will become partial negative charge. This chlorine will also become partial negative charge. And this beryllium will become partial positive charge. Some positive charge will be gained over here. Yes? Yes or not? So a dipole is generated in this direction, plus to minus. Another dipole is generated in this direction, plus to minus. Yes, it's a linear molecule. One dipole is generated in one direction, another dipole is generated in another direction, and the amount of both the dipoles is same. Why same? Because the atoms are same. So what will be the resultant dipole? What will be the resultant dipole in this case? Tell me first, what is the resultant dipole? The resultant dipole will be zero, right? They will be cancelling each other, yes or not? They will be cancelling each other. The vector you had studied already in physics. Okay, so they will be cancelling each other. Okay, one dipole is generated in this direction, another dipole is generated in the opposite direction with the same amount. Obviously, the resultant dipole will be zero only. So since the resultant dipole is zero of BeCl2, so BeCl2 molecule is, I am just introducing a term, is called non-polar molecule. Though there are two dipole moments individually present in it, but the resultant dipole moment of BeCl2 is zero. Why? Because the two dipoles are cancelling each other. Okay. But if we talk about water, what is the structure of water? It's bend. Do you know it's bend? Sorry. HOH, it's bend. We know it. Okay, that it's bend. H4H, it's bend. Fine. Now oxygen here is more electronegative. We know this. That means it will gain partial negative charge. The hydrogen will gain partial positive charge. Here also this hydrogen will get partial positive charge. So there will be one dipole moment in this direction, positive to negative I told. Another dipole moment will be generated in this direction. Yes? Yes or not? So if these two dipole moments are generated according to law of parallelogram, you know this, na? You know this vector laws. The resultant dipole moment will be like this. It will be like this. There will be a resultant dipole moment in this direction. So is water molecule, what I want to say is that, is water molecule polar or non-polar? It is a polar molecule. Okay, because as a whole there is a resultant dipole moment. So it is not necessary that a molecule having dipole moment has to be polar. A molecule having dipole moment might be non-polar if the dipole moments that is present in the molecule are cancelled. Is it clear? I hope this term, yes?
Sir, can you please repeat?
Which one? See, BCl2, there are two dipole moments of it.
H2O part.
H2O, there are two dipoles are generated. Both are generated between H and O. H and O, it is generated from positive to negative, right? Another H and O, it is generated from positive to negative. These are the two dipole moments. If these are the two dipole moments, what is the resultant dipole moment? Law of parallelogram, you know this, na? It will be the diagonal of the parallelogram. Okay, so
Yes.
it will generate like this. This is the resultant dipole moment. This is the result. Forget about this diagram. This is the thing. If these two dipole moments are there, this is the resultant dipole moment. Yes, that means H2O molecule as a whole has got a dipole moment. But does BCl2 molecule as a whole has got any dipole moment? No. Why not? Because the dipole moment that is present in BCl2 molecule are cancelled. But the dipole moment that is present in H2O molecule are not cancelled. They are producing another resultant dipole moment. Hence, BCl2 molecule is called non-polar molecule. Non-polar molecule. From the word itself, you can understand that. Whereas H2O molecule is called what? Whereas H2O molecule is called polar molecule. Yes. So you understood dipole moment. You understood non-polar molecule. You understood polar molecule. I just wanted to give you the concept, but that's all. Okay. You understood the concept or not, that is more important. You understood polarity. Polarity is because of the electronegativity difference. What is dipole, you understood. What is dipole moment, you understood. Charge into distance. Okay. Now whether the dipole moment is present in the molecule or not, we can get it. Now all these dipole moments present in the molecule, will they have a resultant dipole moment or not? If they have resultant dipole moment, the molecule itself is polar. If they don't have the resultant dipole moment, if the dipole moments are all cancelling each other, then the molecule will be called non-polar. I hope you all understood this. Yes or not? These terms are clear to you. I hope yes.
So what will be the application of this?
Yes, we'll do. Don't worry. We have got a lot of application to be done. Okay, in the next 2 years.
Okay, sir.
Next 2 years we have to do a lot of application to be done with this. We can explain so many things with this. Okay, but at this moment, as I told, I am just giving you the concept. The concept should be very, very clear. Okay, so that we can apply whenever the application part will come. I don't have to speak so much. Okay, I will just tell there is dipole moment. That is why this is this. So that you know what is dipole moment. Okay, but is it clear? The concept is clear or not? You tell me that first. Is it clear? Very good. Okay.
Yes,
So very good. Very good. So we are going to do the next theory. We are going to start with the next theory, which is actually tried to overcome the limitations of the what is that called valence shell electron pair repulsion theory. Is called valence bond theory. We write it as VBT, valence bond theory, which we are going to do in the next class. That is on Monday. Okay. So thank you.